Welcome to the WANdisco Fusion lesson on the Fusion Live Data Client, configuration, and platform integration. The topics covered are as follows: configuration, Classpaths and application integration, Fusion server underlying file system interaction, Kerberos Handshake Token Directory, DSM Token Directory, client bypass, replicated exchange directory, global manual fast bypass, per path manual fast bypass, ignored zones, username, translation, coordinated reads. Fusion client introduction. Fusion replaces the standard client libraries with a Fusion equivalent. This is how Fusion captures and then coordinates file system edits across clusters. The Fusion HCFS, or Hadoop Compatible File System, is the equivalent of the org Apache FS Hadoop file system. The Fusion HDFS is created to cover the additional functionality in org Apache Hadoop FS distributed file system. Clients are redirected by modifying .impl properties in core-site.xml. Not all applications integrate the same way. That's one key point to remember. And extensions exist within the Fusion client to minimize overhead and reliance on the Fusion server. The Fusion client configuration. HCFS uses the concept of implementations for file systems. Different implementations are made available by setting the appropriate FS impl configs. Common impls include S3 for Amazon, map RFS for MapR clusters, and file for local file system access. The impl property defines the Java class the client loads to access that file system. For example, fs.hdfs.impl. By overriding the default class for an impl, we can load our classes to filter and send replicated requests to a Fusion server for coordination. The optional use of a non-default impl to load the Fusion client allows for replication in an opt-in manner, rather than just at the regular folder level. An example of this command could be Hadoop fs-ls fusion : with 3 slashes, and that will list the directory in the Hadoop file system. Another way to do this is hdfs-dfs-put temp file into path. That's a regular intercept, and to remove the Hadoop distributed file system impl, you could use that hdfs-dfs command with the -D option for the put. Fusion client and Classpaths. Applications that use the standard HDFS Classpath integrate easily with Fusion. This is the user HDP current Hadoop-HDFS-lib. Yarn, HBase, Hive, Pigscoop, Flume just need restarting after Fusion is installed, so they pick up the new configs. And when you do a Fusion install, you'll see, if you look at, for example, an Embari cluster installed in Hortonworks, that the services do need restarting several times during an install. Some applications have their own class paths. These might need special configuration to find the Fusion libraries. These are services such as MapReduce, Tez, Spark, and Tomcat-based applications like Solar, Uzi, Phoenix. Many of these are catered for via Fusion Installer, RPM scripts, Cloudera parcels. The Fusion Installer automatic configurations. MapReduce is covered with the opt WANdisco Fusion client live star. You can see the class path is modified there, the MapReduce application class path. Tez, the Tez cluster additional class path .prefix points to the opt WANdisco Fusion client lib star libraries. And Spark2, Accumulo, Uzi, and Atlas create a symbolic link to the appropriate directory for the Fusion jars. Configuring Spark.1.x for Fusion. It's not as easy as Spark2. You have to bundle the Fusion jar files in the Spark assembly jar file. You can see the instructions on this slide. They're also in the product documentation. The point is, when you're doing an implementation or a POC and they are running Spark 1, you have to do this assembly jar packaging, and the documentation explains how to do that. Configuring Tomcat-based apps for the Fusion server. Tomcat applications don't make use of the Hadoop class path, but will reference the core site XML. This results in the Fusion HDFS class not found error. If you encounter that, that's where you start looking. Two levels to consider though: the application itself and having the jars available to the embedded web server's class path. An example applications include Solar and Uzi. This is a typical WebInf lib folder, similar to the ones that follow here on the screen. You change directory to the opt web apps, user apps, application WebInf live, copy the WANdisco Fusion lib directory, netty jars, and other jars into that directory. Uzi is catered to by the installer. The jars are copied to the var lib Uzi. If the web server can't find the jars, symptom likely to be job failure with a 500 internal server error. Check the logs, and that's the easiest way to find it. Configuring Phoenix for Fusion. It's SQL on HBase, and integration is required. Fusion client jars are added to the class path. The Fusion installer does not auto-deploy. It involves editing open source scripts. You can see in the Phoenix _utils.py, add the line, the Phoenix class path to the Fusion jars. The Phoenix query server.py, add the Phoenix utils Phoenix _class path to the Java command line. Here's what an example would look like. Consult the documentation if you run into issues when Phoenix needs to be configured for Fusion. Web HDFS, HTTP writes to the name node. This allows the curl calls to the name node on port 500.70 to write to HDFS. And here's an example of a curl line to put HDFS with an HTTP command. HTTPFS is a server that provides a REST HTTP gateway interoperable with the web HDFS REST HTTP API supporting all HDFS file systems operations. This is created to solve the problem of name node high availability with web HDFS. But this can load the Fusion client too with this command. And now web HDFS calls can be replicated. This is seen in Hue, Nox, and Mbari views. For example, some of the views that you can look into for Mbari, that would be like HiveView or HiveView 2. Other third-party software. There's a large growing list of third-party apps that come with the Hadoop adapter nowadays. Typically this means their own set of HDFS libraries are required to read or write files on the cluster. The two key elements for an app to work with the Fusion client are being able to locate and reference the Fusion client config parameters. That would be in the cluster's core site XML, and being able to locate and load the Fusion client jar files. Those are the two key areas. For the config parameters, if it uses an HDFS client, for instance, the app sits on a cluster edge node, it should be okay. The core site XML will have the Fusion parameters. If they interact with HDFS from within the app, it could need further investigation to identify the equivalent core site properties that need updating. For the jar files, the same applies. If they use HDFS, the client, then Fusion jars can be added to standard Classpaths. If the app uses its own libraries to access HDFS, it could be harder to figure out what goes wrong and where the Fusion jars need to be located. You should contact your vendor, the vendor of that app, to find out where the update should be made. Some examples of these are Informatica, Ab Initio, and SyncSort, the ETL tools that load data into Hadoop clusters. Fusion server underlying file system interaction. Fusion writes to local clusters via the core site XML fs.fusion underlying fs. Fusion installer sets this at install time to point to the name node, or for name node HA high availability to the name service ID. Enabling name node high availability changes values like the fs default fs and the fs Fusion underlying fs properties, so these will need updating too. They need to point to the name service ID instead of a single name node. Platforms with custom .impls, for example, MapR, Fusion doesn't by default override the native impl with the Fusion HCFS. One option is to just use the Fusion URI. That's Fusion : with 3 slashes, forward slashes. You can also redirect the fsmap rfs.impl to Fusion HCFS. Then the Fusion server uses the underlying FS class to load the native impl on behalf of the client. This all can be overwritten with any class as well for specific configurations. Object stores typically have multiple options for addressing a namespace. Here's an example: a Hadoop fs-put, temp my file into the map rfs : // Kerberos Handshake Token Directory. In order to authenticate Kerberos users, Fusion requires that a user create a Handshake Token Directory to authenticate. By default, this is set to the user's home directory. Those users aren't always created, so care must be taken to understand if those directories are present or not, and they may need to be created. As not all users will have that home directory, the Kerberos Handshake directory is a central location where all the tokens can be created. Configuring the Handshake token.dr to be, for example, /WANdisco /token, then the Handshake tokens will be written to the WANdisco tokens.fusion token username UUID, where the $sign username is the username of the user connecting, and the UUID will be a random UUID. The Handshake token directory can be configured on initial install or via the Kerberos section on the Settings tab in the Fusion user interface. This should be configured across all zones and requires that directory is readable and writable for the Fusion user that is running. Once enabled, a restart of the Fusion server along with the distribution of the core site XML will be required. That means the changes in the core site XML will have to be distributed to all the data nodes and the edge nodes. The distributed state machine token directory, when a replicated path, and that's what we call a distributed state machine, is created, a .fusion directory is created at the root of that path. The .fusion directory is used to store the metadata for this path. Some of the items it stores are file name, permissions, and owner. and is used for consistency checks and repairs. An example of the contents of the .fusion directory for a replicated path are as follows. So if you perform an HDFS DFS -ls minus $R on the WANdisco/test directory, that would be a replicated path or a distributed state machine. You will see that in the WANdisco test directory there is the .fusion directory and all the files that are created beneath it. Having this directory at the root of a replicated path can cause issues for some services. An example of this is HBase. In this case, we can set a single location for all .fusion directories using the fusion.dsm token directory set in the core site XML. And you could do that as follows. This property will then need to be set in all zones and must be done before the creation of the replicated path. So you wouldn't create the replicated paths first and then set this. You would set this first and then create the replicated paths. But once enabled, a restart of the Fusion server along with the redistribution of the core site XML is required. Client bypass. When Fusion servers go down, clients would by default time out, just like if the name node was down. There's an option to enable the Fusion client bypass. It can be done in the UI settings, or you can configure it manually in core site XML by setting the fusion.client bypass to enabled. In the event of a connection refused, the Fusion client can bypass and write directly to the name node. It's not coordinated anymore. No replication is going to take place. And if the data needs to be synced, a consistency check and repair operation on that replicated path will be required. The replication exchange directory. This is a location in HDFS where the Fusion server will write all the information about replicated directories for clients to read. It should be a non-replicated location, readable by all users and writable by Fusion. Enabling this directory provides the clients a lookup of all replicated paths rather than querying Fusion server on write. If a Fusion server is down, writes to non-replicated paths are not affected. The replicated exchange directory is shown to be working correctly when an OK directory is present. The replicated path secure hashes can be calculated as follows with the echo -n replicated path pipe sha1 sum command. This directory can be figured in the settings tab under replication. It also involves a modification to the core site XML, adding the following property: fusion.replicated.dir.exchange and the path to the replicated exchange directory. Once the Fusion server is restarted, it's enabled, and the core site XML needs to be distributed across the cluster, as always when core site changes are made. This should be configured on all Fusion nodes across all zones. Here's an example of the contents of the exchange directory once set up. You could do an HDFS DFS -ls on the replicated exchange directory, and you could see that the WANdisco replicated exchange directory will have various directories in it. In order to allow clients to contact the Fusion server again, we will just delete the bypass directory from the exchange directory, and we will see this here by adding a bypass directory. This is called the global manual fast bypass. By adding a directory called bypass, you can force all writes, including writes to replicated paths, to bypass the Fusion server entirely and go straight to the name node. So the cluster will operate as if Fusion doesn't exist. You can see that same command, hdfs dfs -ls, to the WANdisco REPL directory exchange, and you can see in this case here we have a bypass directory in place. This will prevent any replication from occurring on that cluster. In order to allow clients to contact the Fusion server again, delete the bypass directory. Upon detection of the bypass directory in the replicated exchange directory, all Fusion clients bypass the server, in effect turning off all proxying of requests. This is useful for halting proposals from the zone. Can be useful in upgrades, troubleshooting, or in the initial seeding for data migrations. And as stated before, we simply delete the bypass directory from the exchange directory to allow Fusion clients to start working again. With Fusion 2.12, the per path manual fast bypass is now available. This extends the idea of the bypass flag to create optional flags for individual replicated folders. So unlike the global manual bypass that's all or nothing on the cluster, this per path manual bypass will allow you to stop replication or enable replication for particular folders. Here's an example of the utility, the bypass-utilities. With the help command, you can see the bypass with a path. That could specify a path to bypass. Can be used more than once. The -C or -C that specifies an application configuration file. The -R or the -replicate specify a path that should be replicated. This gives you much more control over the ability to bypass Fusion for debugging purposes, for selective initial loads or migration purposes. It's much deeper and much more complete than the prior global fast bypass. Per DSM, distributed state machine manual fast bypass. It's controlled independently of the Fusion server on purpose. It's a client-side ability to override what is and isn't proposed for replication. The REPL path and exclusions are defined in the server. The path bypasses are applied over this in the client. This means we can bypass a folder without having to remove the distributed state machine itself, without having to move the replicated directory from Fusion. It allows us to gradually introduce live replication as each folder is seeded at the destination. For example, that would mean consistency check and repair only folders until we're ready for full replication. You can have a live active and active passive replication set up between the same clusters. For example, that would be useful in an HBase situation. And this could be used as a per zone exclusion option. Ignored zones. This will be introduced in 2.12.1, not GA as of this recording. This allows for a zone to be told not to execute any particular proposals on a path from a particular zone. And the question would be, well, why would we need this additional option? The per path bypass prevents proposals from a zone source being proposed to all other zones. The use cases are Zone A repair to Zone B, but not Zone C. Another example, Zone A replicates to B and C. Let's say B and C are both cloud regions, and B and C replicate to each other, but not A. You need an option to prevent a proposal from being proposed at specific zones, and this ignored zones enables that. Username translation. A pattern matching system used to translate users between clusters where there are differences. You could see this in an example where one cluster 1 might have a user called HDP-prod, but cluster 2, the user should be named CDH-prod. To use that example, you set the Fusion username translations properties in application properties of cluster 2 as follows. The Fusion username .translations, and you could set the HDP dash. You can see the $* in parentheses /CDH $1. What that will enable is it'll say that HDP-prod will appear as CDH-prod in cluster 2. Patterns and translations are separated by /. Patterns and translations don't contain the /. Multiple rules can be used and are comma separated. With this username translation, a restart is required for it to take effect, and like with most configurations where a bit of a programming type script is required, several tests and experiments might be required in order to get it right. More information on this could be found in the WANdisco docs, Big Data Fusion 2.11 Username Translations section. Coordinated reads. By default, open requests are not bypassed to the Fusion server for coordination, and this is typically 75% of the requests on an HDP or Cloudera cluster. It's an unnecessary no op, in quotes, when coming from the source cluster. If there is a requirement for a guaranteed read after write, this can be enabled in the core site XML by enabling the Fusion client coordinate read equals true. It's relevant for remote zones attempting to read data very early. This concludes the WANdisco Fusion lesson on the Fusion Live Data Client, configuration, and platform integration.